Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 18, page 175, lecture number 29, and chapter name is Atomic and Nuclear Physics. Today topic is half-life. What is half-life of a radioactive substances? The half-life is the amount of time it takes for a half of the atom in a sample of radioactive substances to decay. Decay means disintegrate from one element into another element. Half-life is also defined as the time it takes for half of the original substances to decay away. For example, if you have a naught original number of atom, so the time half-life you will write 1/2. It is the time during which these elements reduce to half. So time t 1/2 is equal to 1/2 in naught. So the time during which the element is reduced to its half is called half-life. After a time interval equal to 1/2, there are n/2 radioactive nuclei. So this is the, for example, if you have originally 100 number of atoms, so 1/2 in naught is 50. So the duration of time in which the 100 number of element is reduced to 50, in which 50 atoms decay, is called half-life. After two half-lives, half of these remaining nuclei have. So if second half-life, after second half-life, the number present will be reduced to 1/4 in naught. So the general equation will become n is equal to 1/2 in naught, and 2 power is n. You can write it like this. So I will explain. For example, number of original atom is n1 in naught. After first half-life, 1/2 in naught. After second half-life, 1/2 multiplied by 1/2 in naught. First half-life, second half-life. Third, 1/2 multiplied by 1/2 multiplied by 1/2 in naught. So the total will become 1/2 power n in naught is the number of atom after half-life. So this is the general equation. For first half-life, we must obtain this thing. N is equal to 1/2 in naught. When you put n is equal to 1 first half-life, for n is equal to 2, we will write n is equal to 1/2 2 in naught, and so on. So half-life is the duration of time during which the element is reduced to its half. Now, nuclear fission reaction. Fission reaction is the disintegration of heavy nucleus into smaller nuclei. Heavy nuclei into smaller. Fission occurs when a neutron slams into a larger atom, forcing it to excite and split into two smaller atoms, also known as fission products. Additional neutrons are also released that can initiate a chain reaction. When each atom splits, a tremendous amount of energy is released. During fission reaction, a large amount of energy is released. Uranium and plutonium are most commonly used for fission reaction in nuclear power reactors. because they are easy to initiate and control. Energy can be released by fission in these reactors. Heats water into steam. Steam is used to spin a turbine to produce carbon free electricity. Now, this is uranium atom. Neutron hit the uranium atom. Here neutron is absorbed. So 236, 235 atomic mass number will be increased by 1. Then 3 neutron is released. Barium and krypton are released. So when uranium is bombardment, when neutron hit the uranium 235 92, it is converted to uranium 236. After disintegration, the formation of krypton and barium take place with the release of 3 neutron. Fission versus fusion reaction. Physical process that produce energy from atom. Both are physical process in which energy is produced. In fission, heavy nucleus is disintegrated into two smaller nuclei, and in these two smaller nuclei combine and heavy nucleus is formed. Now I will write the reaction for nuclear fission process. Neutron hit the uranium 235 92 with the release of barium and krypton. Barium 141, 144, 144, charge number this. Krypton 89, 36, plus with the release of 3 neutron. The release of 3 neutron. Now, inside information in book is given that electron volt is the unit of energy. Is the unit of energy. Now, if further uranium are available, or you cannot control these 3 neutron, it further causes a 3 nuclear reaction, and during each reaction 3 neutron is released. So in next step, in first step there is only one chain reaction, nuclear reaction. In the second step there are 3 nuclear reaction, and in the third step it is the nuclear reaction amount increases to 9. So if you cannot control the number of neutron, it causes chain reaction, nuclear chain reaction, and will causes destruction. Chain reaction is a nuclear reaction which is an uncontrolled nuclear reaction is called chain reaction. An uncontrolled reaction is called nuclear chain reaction. Now next, nuclear fission reaction. Fusion reaction occurs when two atoms slams together to form a heavy atoms, like when two hydrogen atoms fuse to form a helium atom. Deuterium, tritium, protium, deuterium. When it fuses, heavy nuclei is formed. This is the same process that powers the sun and creates huge amount of energy, several times greater than fission. It also does not produce highly radioactive fission products. Fusion reactions are being studied by scientists but are difficult to sustain for a long period of time because of the tremendous amount of pressure and temperature needed to join nuclei together. Huge amount of energy is needed. For example, deuterium and tritium fuse up and helium nuclei is formed plus with the release of neutron. So when deuterium H2 1 plus tritium H3 fuse up, helium nuclei is formed plus with the release of one neutron plus energy. Now comparison between nuclear fission and fusion reaction. Fission reaction does not occur naturally. Fusion reactions occurs in stars such as sun. On the surface of sun nuclear fusion reaction, the energy released on the surface of the sun or we get the energy from the sun is released during fusion process. It produces many highly radioactive particles. Few radioactive substances are produced. Energy released is million times greater than that in chemical reaction but lowers that the energy released by nuclear fusion. Particles are produced by fusion reaction but require fusion triggers. Energy is released 3 to 4 times greater than the energy released by fission. So during fission process, less energy is released as compared to fusion process. But during fission process, larger energy is released as compared to chemical process. Now we will revise now. This chapter is finished. Tomorrow we will do the numericals. Atom. First we studied the atoms are atom structure of atom. An atom is the smallest particle which is divisible. Atom consists of two parts, nucleus and the circular parts. In nucleus, neutron and proton is present. Atom rotate around the nucleus. Mass of proton is 1.673 cross 10 raised to power minus 27 kg. Mass of neutron is 1.673 cross 10 raised to power minus 27 kg. A little difference. Mass of electron is equal to 9.11 cross 10 raised to power minus 31 kg. Electron have a negative charge, proton have positive charge, and neutron are neutral particle. Neutron located inside the nucleus. Having mass equal to 1.67375 cross 10 raised to power minus 27 kg. No change or neutral. Atomic mass number. Number of neutrons, number of protons, mass number. When number of neutron combined with the number of proton, atomic mass number is formed. Charge number is the number of proton in a nucleus. Isotopes are the element which have same number of neutron. Proton, number of positive charge particle. So isotope have same number of proton but different number of neutron. isotope. Three isotope of hydrogen atom. Protium, one proton, one proton, one proton, zero neutron, one neutron, two neutron. So protium have one proton, but neutron is zero. It have one neutron. It have two neutron. Radioactivity. Spontaneous emission of nuclear radiation. Spontaneous emission of nuclear radiation. Spontaneous emission of nuclear radiation without any external help. Without any external help. During natural radioactivity, three radiation are emitted. Alpha particles, beta and gamma rays are emitted. Now, gamma rays have more penetrating power. More penetrating power. Gamma rays have more velocity. Beta rays have less penetrating power. Less velocity. Less velocity than beta. Penetrating power is less. Power is less than beta and alpha. Beta and gamma. Mass is more. Alpha particle have greater mass than beta and alpha, gamma. So due to heavy mass, alpha particle have less penetrating power. Alpha particle have double positive charge. Beta particle have single negative charge. Gamma particles have no charge. So beta particle is less ionizing as compared to alpha particles, and alpha particles have greater ionizing power due to double positive charge. Gamma particles have neutral particle, less ionizing than alpha. Background radiation. The ground radiation is caused by radioactive substances. The radiation present in the atmosphere is called background radiation. Transmutation. The disintegration of one element into another element. Disintegration of one element into another element is called nuclear transmutation. Uranium-238 disintegrate into thorium with the release of alpha particles. So when uranium is disintegrated into thorium, this disintegration is called nuclear transmutation. Thank you, students. Allah Hafiz.